Let us look at proposition number 28 of book 6 of Euclid's Elements. The proposition says to apply a parallelogram equal to a given rectilinear figure to a given straight line, but falling short by a parallelogram similar to a given one. Thus, the given rectilinear figure must not be greater than the parallelogram described on the half of the straight line and similar to the given parallelogram. So basically, what the proposition is saying is that we have to construct a parallelogram equal to the figure but falling short by a parallelogram similar to the given parallelogram. Now let's start the construction. Let's break this figure C into triangles. So we have got two triangles. That is one. Second is we find the midpoint of AB. On EB, we construct a parallelogram similar to D, and we know how to do that. So I'll just directly present it, and let's mark these endpoints G and F. So EBFG is similar to D. Now, inside this parallelogram, we construct parallelograms equal to each of these triangles. So let's take the midpoint of this triangle, any one side, and let's construct a parallelogram on top of it so that this parallelogram area is equal to this triangle area. Similarly, we take the midpoint of this side and we construct a parallelogram whose area is equal to this triangle's area. Now we copy these parallelograms here so that the areas are equal. Now instead of doing it on EB, I'll do it separately so that I can move it around. You will see what I mean by that. So this is our parallelogram equal to this parallelogram, and I have drawn it, independent of EBFG so that I can move it around. Okay. Similarly, we construct a parallelogram along this green parallelogram equal to the orange parallelogram. So now if you notice, if I position it, it will exactly fit onto EB. Okay. Now we are left with a remaining parallelogram in EBFG. So this is GB, and this green and orange put together is nothing but C. So the remaining part of the parallelogram or the remaining parallelogram would be GB minus C. Let me construct a parallelogram equal to this parallelogram, the remaining part, separately. Okay, so this is GB minus C. And if I again move it, it will exactly fit into that. Okay, so let me take it out. Let me take this out. Now, remember, we are not interested in this itself. We are interested in a figure equal to this area, but similar to D. Again, we are going to convert this into a parallelogram similar to D. Now, how do we do that? So for that, along D, I will construct a parallelogram equal to this. Again, we know how to do this. And I will take this side is to this side. I will take the mean proportional of these two. I have done it separately. Yes. So using that mean proportional, we are going to construct a parallelogram which is equal to GB minus C and similar to D. So let me mark the points on this parallelogram. So remember, KLMN parallelogram is similar to D and equal to GB minus C. Again, if you notice, if I move this, it will fall exactly along the diameter GB. Okay, so let me just draw that diameter so that you can actually see this. N falls exactly along GB. Since we can position it here, we can say that Km is similar to EF or GB, which means we are ending up with a gnomon. Now I will copy Lm to GF, KL to GE. So P and O, and I'll complete the parallelogram. So it is as good as me dragging and dropping. But here I want a little bit more precision. Till now you might have noticed that on top of AE we have nothing. So we now complete the parallelogram. So let's join these and make the parallelogram complete. Now once we have done that, let's extend OQ in both the directions and PQ to EB. So let's take it one by one. This parallelogram, that is TS, is the required parallelogram. On AB, falling short by a parallelogram which is similar to D, and the area of TS is equal to the area of C. Just saying it is not enough, right? So we need to prove this. So to prove this, let me remove this and let's take it step by step. Now we know parallelogram GB is similar to parallelogram D. Parallelogram HE is equal to parallelogram GB because E is the midpoint of AB. Now if parallelogram GB is equal to figure C, GB itself is equal to figure C, then you notice our requirement is that it should fall short by a parallelogram similar to D. If GB is equal to C, then it is not going to fall short. So basically that implies this condition. Let me move this and let me increase it. Okay. Now you see, it is not falling short. We need that falling short by a parallelogram similar to D. So we can't have that. So which means parallelogram GB has to be greater than figure C. If parallelogram GB is greater than figure C, then we proceed further. We know parallelogram KM plus figure C is equal to parallelogram GB. And we have seen this. If I put this here and I put this here, then it is exactly equal to GB. So GB minus C is this. This is C. So GB minus GB minus C will give us what? It will give us C, which means GB minus C is the remaining part of GB. That is this gnomon. And that we can say because Km is similar to D, D is similar to GB, and Km is similar to GB, which means parallelogram GQ is equal to parallelogram KLMN. That means all these parallelograms are similar to each other. Because of this, the remaining part of this is equal to, that is this part called the gnomon. Gnomon is equal to figure C. Okay. Now parallelogram PR is equal to OS. Why? Because they are complementary parallelograms along the diameter. Now to this equality, we add QB to both the sides. So we have parallelogram PR plus parallelogram QB is equal to parallelogram OS plus QB. But PR plus QB is nothing but PB, and OS plus QB is nothing but OB. But OB is equal to PE. Why? Because E is the midpoint. So which means parallelogram PB is equal to parallelogram PE. PB is equal to PE. Parallelogram OS plus parallelogram PB. OS plus PB is equal to C. We have already seen gnomon. Gnomon OQPFBE is equal to figure C. But that gnomon OQPFBE can be written as OS plus PB. So that is equal to C. Now OS plus TE is equal to figure C. What we are doing is we are substituting PB by TE. So that means parallelogram TS is equal to figure C, which is what was required. So now let me bring that highlighting. So this is the required parallelogram on AB, falling short by a parallelogram which is similar to B. So that is proposition number 28 of book 6 of Euclid's Elements. Now, this is, you need to strictly follow the proposition while constructing. Then only you will be in a position to do this. See, when everything seems to disappear, figure C has become larger than this parallelogram. If I make it smaller, everything reappears. Yes. We can actually move this, we can resize parallelogram D. Everything automatically gets redrawn. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and in case you feel somebody else can also benefit from it, please do share it. That's it for now.